For this week, let's have circles and other related terms for our week number 4. Let's have the theorems related to chords, arcs, central angles, and inscribed angles. In a circle or in a congruent circles, two minor arcs are said to be congruent if and only if their corresponding central angles are congruent. So we have in here triangle CAD and triangle BAD are said to be right triangles at A. So arc CD is congruent with arc BD. So this is the given from the definition of a right angle. So we have this. Then all right angles are said to be congruent. And then we have the definition of the congruent angles. So the central angle and the intercepted arc have the equal measure. So if angle CAD is equal to angle BAD, therefore arc or the intercepted arc CD is congruent arc BD as well. In circle E below, so we have circle E, angles SET is equal to 50 degrees is congruent with angle NEO. Since the two central angles are congruent, the minor arcs that are said to be intercepted, which are arc ST and arc ON, are said to be the intercepted arc. Therefore, it is said to be arc ST is also congruent with arc NO. If circle E is congruent with circle I and angle SET is congruent with angle NEO, therefore, it is also congruent with angle BIG. Then, arc ST is congruent with arc NO and congruent with arc BG. Okay, let's have in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are said to be congruent. So, line segment AB is congruent with line segment CD. So, we need to prove that arc AB is congruent as well with arc CD. Now, this is the given. Now, by the construction of the definition of the triangles, so we have triangle APD and triangle DPC. Next, the radii are said to be on line segment AB, line segment BP, line segment DP, line segment CP are said to be the radii of circle P. Therefore, they are said to be congruent. So, triangle APB and triangle ACD are said to be congruent as well using the side-side-side congruence postulate. Therefore, angle APB is congruent with angle CPD. Using the corresponding parts of congruent triangles are said to be congruent as well. So the measure of angle APB and the measure of angle CPD is also congruent since the definition of congruent angles. And the measure of angle APB is equal to the arc or the measure of arc AB. Since we have the measure of central angle of central is equal to the measure of the intercepted arc. So with that, we just need to have the substitution. We can say that arc AB is congruent with arc CD. Another example we have in here, circle T, wherein we have line segment AB is congruent with line segment CH. So we have two chords. Therefore, arc AB or arc BA is congruent as well with arc CH. So if that's so, circle T is congruent with circle M. Therefore, line segment BA is congruent with line segment CH, congruent with line segment OE. Then, arc AB is congruent with arc CH and congruent with arc OE. Now, in a circle, diameter bisects chord in an arc with the same endpoints if and only if it is perpendicular to chord, to the chord. So, we have the diameter, we have line segment AB. We have the chord, line segment FD, There you go. In circle U, line segment ES is a diameter, and line segment GN is a chord. Now, it is said to be perpendicular. Kaya lang pwedeng sabihin perpendicular if and only if it forms a right angle, no? So, this sign gives you, no, it shows that angle GIE and angle NIO is said to be right angle. So, perpendicular sila. Now, with that, we can say that line segment ES is perpendicular with line segment GN. Then, line segment GI is congruent with line segment IN. And with that, arc GE is congruent as well with arc EN. Now, let's have the inscribed angles, intercepted arcs. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So, we have in here figure 1. So, we have angle LAP, wherein the intercepted arc is arc LP. Then, we have angle TOP as inscribed angle, and the intercepted arc is arc TP. And then, we have angle CGM, and then we have the intercepted arc CM. So, if an angle is an inscribed angle, inscribed in a circle, then the measure of the angle equals 1/2 of the measure of the intercepted arc. So, angle ACT is an inscribed angle. The intercepted arc is arc AT. So, if the measure of arc AT is 120, therefore the measure of angle ACT is divided by 2 of the measure of arc AT. So, 120 divided by 2 is 60. So, that is the measure of angle ACT. If two inscribed angles of circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent as well. So, figure 1, we have angle PIO, and then angle PLO. So, they are said to be with the same intercepted arc, which is arc PO. Since angle PIO and angle PLO intercept the same arc, then the two angles are said to be congruent as well. So, in here, if an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. So, angle NTE. So, the intercepted arc is arc NSE. Now, if arc NSE is a semicircle, because the chord or the diameter, no, we have line segment NE. So, it divides the circle into semicircles. Therefore, arc NSE is said to be a semicircle. Then, angle NTE is a right angle. So, the measure of angle NTE is 90 degrees. So, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So, we have a quadrilateral DREA inscribed in circle M. Therefore, the measure of angle RDA plus the measure of angle REA is equal to 180. And the measure of angle DRA, no? DRA is equal plus angle DAE. This is supposed to be the measure of angle DRE plus the measure of angle DAE is equal to 180. Now, let's have the tangent line. A tangent line to a circle is a line coplanar with the circle and intersects in only one point. The point of intersection is said to be the point of tangency. So, line PQ intersects with circle C at A, at point A. Therefore, point A is said to be the point of tangency. So, let's have the postulate on the tangent line. So, At a given point on a circle, one and only one line can be drawn that is tangent to the circle. So, in circle V, no? So, we have in here point U as the point of tangency of line A, no? So, we only have only one point of tangency. Okay, so let's have the theorems on tangent line. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So, line AB is tangent to circle Q at R. Then, it is perpendicular to radius QR. Then, number 2, if a line is perpendicular to a radius of a circle and its endpoint that is on the circle, then the line is tangent to the circle. So, line CS is perpendicular to radius LT. Then, it is tangent to circle T. So, if two segments from the same exterior point, when you say exterior point, nasa labas yung point, no? Are tangent to a circle, then the two segments are congruent. So, tingnan natin ito. So, if line segment DW and line segment GW are tangent to circle E, then we have line segment DW is congruent line segment GW. Now, let's have the common tangent. A common tangent is a line that is tangent to two circles in the same plane. So, we have the common internal tangents wherein we have intersect the segment joining the centers of the two circles. So, we have it here. Next, let's have the common external tangents wherein do not intersect the segment joining the centers of the two circles. Now, let's have the second of a line. So, second is the line that intersects the circle at exactly 2 points. The second contains a chord. So, we have in here line MN as your second line. No? Then, we have chord that is chord or line segment.